You are driving up a long inclined road. After 1.2 miles, you notice that signs along the roadside indicate that your elevation has increased by 530 feet. What is the angle of the road above the horizontal? And how far do you have to drive to gain an additional 150 feet of elevation? So let's draw our picture. And we're going to say this is where we started. And this is 530 feet. And then we'll drive another 150 feet. And then the distance along between here and the start is 1.2 miles, which I'm going to convert straight up. Actually, let's leave that in miles since we're probably going to answer the other thing in miles. And then finally, I guess we should say that the angle, which is what they're asking for, the angle of the road above the horizontal, I'm going to call theta. I don't know its value yet, but that's what we're going to figure out. All right, so in part A, we want to say that we have a triangle. I'm going to redraw a triangle, badly in that case. I'm going to redraw the triangle. It doesn't have to be the same scale or anything. I'm just trying to make my triangle explicit. So what we have here is that our hypotenuse is 1.2 miles, and our opposite side is 530 feet. And they're in different units, so at some point I have to convert, but that's not relevant at the moment. And then remember, this is our angle theta. And by construction, heights of elevation are always perpendicular to the horizontal, so we have a right triangle, which is good because otherwise our trig is kind of messy. And then we go and we say, in a right triangle, we have that the sine of the angle is the opposite over the hypotenuse. So the sine of our angle is 530 feet over 1.2 miles. And then I'd better convert it because now I actually want to get a number out. So I'm going to convert from, I'm going to convert the feet back into miles because I want to answer the later thing about how far in miles. So it doesn't really matter which way you go. So I can say that there is 1 mile in 5,280 feet. And so all told, that comes out to be 0.08365. I'm going to go to 4 digits, 4 significant figures. It's actually really hard to know how far we should carry stuff with trig functions. Here, I guess we really should only have two significant figures. So I should probably really call this 0.084. All right, and then we move forward by saying, okay, but if that's the case, then let me apply the inverse sine to my equation. The inverse sine being a function that undoes the sine by construction. So we build this so as to say, oh, the inverse sine of the sine of theta is constructed to be just theta. And on the other side, we have a thing that you probably don't know offhand, and that's perfectly fine. You just throw into a calculator. Inverse sine of a number will give us an angle. In this case, 4.82 degrees, which really should definitely round to 4.8 degrees. So the road goes up by about 4 degrees. Well, I guess more about 5 degrees. All right, for part B, we're going to go some additional length that I don't know, up a height that I do know, and the key thing is at the same angle. So also theta, and I know that we have over here, this is now our new hypotenuse, and this is our new opposite, and we can say the new opposite is 150 feet. All right, badly written, so try that a little bit better. 150 feet. And our new hypotenuse, I'm just going to call S. I don't know what it is. And so we again say, oh wait, then basically the same kind of thing applies. The sine of theta is equal to the opposite over the hypotenuse, which will equal 150 feet over S. And then we can sort of just cross multiply and say that S times sine of theta is 150 feet, or S is 150 feet over the sine of theta. And maybe the most important thing to recognize here is that theta is the same. And so we know its sine. So this is 150 feet over the 0.08365, or 1,793 feet, which in terms of miles is 0.34 miles, which seems reasonable. There's actually an alternate way to do this, and I'm going to do that in the next bit. But this would be the solution, and you'd be fine here. An alternate way to do B is to recognize that we have two right triangles, and that they are similar because they share a right angle, and they share the other angle we had. In other words, they're both theta here. So this distance, 1.2 miles, is to S as this distance, 530 feet, is to the new height, 150 feet. And so we could write an equation that read S is to 1.2 miles as 150 feet is to 530 feet, and then solve that over and say S would be 1.2 miles times 150 feet over 530 feet, which comes out to be, hopefully not surprisingly, 0.34 miles. And we can do that without ever getting the angle. All we care about is the angle is constant. Either way is fine.